My name is Artemii, and I want to talk about real-time motion recognition during presentation. I made this project under the guidance of a company, and before I will start, I would like to ask you a quick question. How have you tried to start running? Come on, raise that for your hands. Yeah, running. Okay, only one, two. Nobody started running. Okay. I also started to run, and I found out that it can be boring. But then I found the app Runkeeper, and it became much more interesting because I can find the data about my run, I can analyze it, make myself better, improve myself. So I thought maybe there is something similar like this for the presentation, because presentation can be also boring when you do it again and again and so on, but actually there is nothing like this. And actually this is like a topic of my speech today, and we will talk a little bit about machine learning, about face detection and emotion recognition algorithms. Then there will be also engineering part where I will tell you about the lens camera and realization of the algorithms, and then data part is data analysis and visualization of the results. How can we evaluate presentation? First of all, we can record a video of presenter during presentation and then check his performance. Also, we can recognize pose and gestures of person who present, and the other thing is we take information from audience, not from a presenter, and this is what we want to do. But what are the main reasons that why nobody did start it before? Because there is a big brother issue. Because a lot of people might think that photos or video can be uploaded to the cloud, or maybe they are stored locally. And also everybody is like quite confident about their personal information. And in my solutions there will be no photo uploaded to the cloud, no photos stored locally, and also it uses only aggregated information like from the audience itself, not from each personality. But how it's possible? Well, because I use the lens camera. It's a special camera that also uses CPU and GPU inside. And because of it, we can use like machine learning models inside the camera itself. So we don't need to send info somewhere. We don't need to send it to the internet or save and then do something after it. We can do it like on the fly. So what do we need to make our to make everything works? We need face detection algorithm, of course, and also motion recognition algorithm. So this is easier. And I will start with face detection, especially because there is an Amazon solution there, and there are some pre-configured projects in Amazon library, but there are some problems with it. While the camera can make a video like with really high resolution, 1,500 to 2,500 pixels, in reality their model then reshape it to 300 by 300 picture. And it makes it impossible to like record a big audience. It's only possible to find only 4 or 5 faces maximum. So can we do something with this? Yes, but first we need to solve crowd detection problem. I will start from very beginning. As everyone know, for finding faces we use a frame that goes from left to right and from the top to the bottom. And then to find big faces on the photo, we first reshape photo and then finding the face. Also, for example, when we need to find small face, we don't need to reshape. But what can we do if there are like 2 persons in the same photo and their like difference between their size of the faces is really huge? We cannot do it. As you can see, it either find small faces or either find the big faces. But why can we use both? So the main idea of the algorithms that I used that we can use a pyramidal image approach. We use the original picture, then we reshape it to a smaller one and use it again. Then we reshape it to the even smaller one and we use it again and again and again. and we use a lot of these pictures that can find both a small face and the big face. And one of the algorithms that uses this approach is MTCNN. It's first you build image pyramid, and then you put it through 3 following networks, PNet, RNet, and ONet, and each of them use different frame size and different techniques to make results better. And also between the steps you use non-maximum suppression to find out whether images, faces on the images are the same. Like on the big images, on the small image, it's the same face that we found. So it shows pretty good and fast results, while we needed to do everything on the fly. For example, for full HD resolution pictures, it can work every second. It's also showed good results in very big pictures. As you can see here, it's really hard picture to analyze because everybody face not to the camera, and also everybody, there are a lot of different faces. And if we zoom it here, for example, as you can see, there are a lot of people, and it finds some of them at least. So it's still a good result. And also the second thing, why it's better than Amazon solution, that even when we reshape it to the original 300 by 300 size, it still finds more than 4 or 5 faces. So we are done with with the face detection. Let's switch to emotion recognition. I tried to use Amazon Recognition API first, and then it showed pretty good result. As you can see, for example, here or here, it was a presentation where 2 big jokes were told, and everybody laughed a lot. But there are problems here. First of all, it's privacy reasons. Since it's API, you need to send the info somewhere, like for example to Amazon, and you are not sure whether somebody can use this data or they don't use this data. The second thing is time consumption problem, because sending data somewhere and then getting the results can be even much more longer than do calculation on the machine. And the third one can be pretty hard to understand. It's calm-biased algorithms. So while a lot of people on the presentations are calm and have natural face expression, still we want to check even small changes in the person faces. So to make your own algorithms, you first need data set, and I use PR Plus data sets. It's made up on the famous FAIR dataset. It's a lot of, it's more than 30,000 faces there. And while the FAIR dataset was, it had only 1 person who labeled the data, FAIR Plus dataset have 10 persons for each images, and then they got the best results to show. I used the mini exception network for do this job, and it's really fast and small. For example, when the Inception or ResNet networks have tens of millions weights, the mini exception have around 60,000 weights, and if which weight will be a kilometer, the mini exception will be the path from Munich Hauptbahnhof to airport, and other networks will be length of the equator. So why it's so fast and actually it's showed also good results. As you can see on confusion matrix, it's on the FAIR Plus dataset. It's really good at finding calm and happy emotions. That exactly what we need. And why it's so fast? Because it's used depth-wise separable convolution layer. This layer is using first point-wise convolution and then depth-wise convolution. So first we are going, we take the image with a lot of layers, and then we are going with the filter that has size 1 by 1. And after we go through all the image or all the data, only after this we use as like original depth-wise convolution, but only for each layer. And it shows the same results while it's much smaller. As you can see here, there is an example when the input image have like 100 by 116 channels, and the output has 32 channels with kernels 3 by 3. Like regular convolutional layer will have 4,600 weights, and the separable convolution layer will have only around 300 weights. And also, as I told you before, with the column-biased problem, here you can see this comparison with Amazon recognition. Like here it's Amazon results, and here it's mini exception results. So while all the spaces, Amazon thought that it was column phase, for the mini exception results, it can differentiate it between different emotions. Also, there was like a strange thing that we can discuss afterwards. While I try to train it like every time, I had this strange drop of training loss and validation loss like every time, and then both the validation loss and training loss starting to go to the stable position. So, yeah, while I'm in I end with a machine learning task. Now I need to build it on a deep lens, and there are some challenges that I meet there. First of all, with the Amazon environment, it's impossible to build one model. It's impossible to build more than one model at a time. So there can be like a fix where you put it in the machine, not in the environment, and then like run it from the code with the saved model. Second, you cannot turn on, turn off algorithms. You can only turn on the camera itself, and it can be really hard to test it. Because like you cannot turn off the algorithms and turn off your program, you only need to turn on the whole camera again and then turn on it again. And you can, for example, create a folder there and then check is there a folder created, and then create and delete it like via SSH. The other thing, the other challenge that I need, you can't stack overflowing, and you are only on your own because it's not widely. Not a lot of people work with it, so you can't find a solution, working solution there. And there are a lot of problems with initial and every time setup, for example, Wi-Fi or other different settings. And also, while I did it, Python 3 was not supported, but I fixed it with microarchitecture approach. Like, what is this? It's when you do when you split a lot of tasks to the different parts. And for example, your first algorithm do something, then you send the result that you got to the second algorithm, then it's do also something, then so on, so on. And when the last one did his job, you send everything to the algorithm 1, you send information, then you can start to do again. And I use a watchdog there. It's used iNotify there. It's pretty interesting thing that it checked is there a new file created in the program environment, and because you didn't, I didn't use like a sleep and so on. It didn't use the CPU of the camera. It just used the iNotify messages of the Ubuntu OS itself. So it didn't like spend any CPU there. And then when it checks that a new file was created, it sent it to the function. And the good part of it that it was a unified approach for all the algorithms that I used. And basically, I split it up to the four algorithms. First, I did photo. The second one is the face recognition algorithm. The third was emotion recognition algorithm, and the last one was the visualization of it. And the also good part of this that from now on it can be run on any device like Raspberry Pi, for example, with photo. You just need to switch off the photo algorithm that was made for deep lens with other algorithms that will be made for Raspberry Pi device. Yeah, and then if you are not if you don't like the results of the TCNN algorithm, you also can switch it to the another algorithms without changing the whole environment. And at the end, what can we do with all of this? First of all, you can do online visualization. I used Flask and Bouquet, and the main part here is that I also run it on the device itself. And while it has Wi-Fi, everybody can join to this camera and check the results. As you can see, I also used Ajax here, and it's update on the go. And yeah, you don't need to refresh a page or something like this. And you can like change what emotions you want to follow, what you can check, and so on. And also the other thing that you can also analyze the data that you got afterwards. So it can seem not very valuable, but actually it was like more than 3.5 hour presentation. And as you can see, most of the time everybody was quite neutral, but there was like some happy part at the beginning. And what was that? We can watch it on the closer look. And well, actually this is the part when the presentation began. And this was the part where everybody just sitting and chatting and just waiting for the presentation to begin. But then after some stuff, like there was some business stuff, business task and so on, and then there was like a funny joke spoke and everybody laughed, and you also can see it here like on this peak. And the second thing that we can check, it's a number of the recognized faces, and we can also analyze it. For example, here, as you can see, there are like a big, small amount of faces that it recognized, but actually it was because it was a pause between two different presentations. But actually, if we look somewhere here and look for this one, it was like in the middle of the presentation, and our task and task of the presenter will be analyzed why at this time of the presenter nobody was listening, nobody like was paying attention to the screen, nobody watched the presentation. Its end is the data, and what can be done next? First of all, we can use head pose detection to have better results to the who watched presentation, who watched to the screen, and who watched to their mobile phones, who are not interested in presentation at all. Also, we can run it at mobile device. As I said before, it used microarchitecture approach. We just need to change how it works, how the photo like made by device, and also I guess there should be some psychology research because it's not quite. We don't know what target we need. So what will be the best like graphic? What will be the best results from the presentation? What are we wanting? So do we want that everybody feel happy all the time, or do we want that they sometimes surprise, then they are happy, and so on? So to better understanding all of this, we do psychology research. And at the end, I would like to thank that reply team and Dmitry, Vadim, and Gavin, and also Professor Ungema in the room for helping me. And at the very end, I'm looking for a master thesis. So if you have something interesting, I'm open for this. And here, just feel free to enter on LinkedIn. It's a QR code for LinkedIn page.